Okay, so hopefully by now you have a reasonably good idea of measuring any interval that we'd find on the piano or any other instrument that goes up to 1 octave. We would know that, for example, the distance between these two notes is a major third, and hopefully you'll be able to tell that the distance between these two notes is a perfect fifth, and the distance between these two notes is a major seventh. But what about these two notes? What about this interval here, going from a C down here to an E up here? Now obviously this interval is much bigger, well it's a bit bigger, than 1 octave. And at the moment we don't have a way of talking about this gap, and sometimes we do need to be able to talk about these distances in pitch that are bigger than 1 octave. So how do we do that? Well, one way we can talk about these bigger intervals is to describe them as compound intervals. And all compound intervals is an interval that we already know, but communicating this idea that there's a gap of more than an octave involved. So it's not just a perfect fifth, or it's not just a major third, but it's a major third plus an octave. And that's what we've got here. So the distance between this C here and this E here is a compound major third. And so that's telling us that what we have here is a major third. We can measure this bit. So this little bit of the interval is a major third, and we can work that out by counting our letter names. 1, 2, 3. And so that tells us it's some kind of third, and we can work out that it's a major third because this E belongs in the major scale of C major, and there's our C there. And the reason we can do that is because this octave, we ignore this octave. We know it's there, but we just move this bottom note up an octave to make the calculation of the interval type a little bit easier. So once we've worked that out, we know it's a major third, this top bit. We can communicate to our friends and colleagues that this is going to be a compound major third. So it's not a major third, it's bigger than a major third, it's an octave plus a major third. So when we see a compound perfect fifth, let's say, that's telling us that the interval that we're dealing with is an octave. So, oops, that's not a very good arrow, let's try that again. It's an octave plus a perfect fifth. So it's going to be quite a big gap from the bottom note to the top note. Let's see if we can find a compound perfect fifth starting on this G down here. And what would be a compound perfect fifth above this G? Well, first of all, let's just get rid of our octave bit. So let's cross off the octave and say, well, an octave up from G is this G up here. Great, so that's taken care of that bit. So we know we're going to cover the distance already from this G to this G. On top of that, we need to add on a fifth. So we need to work out what is a perfect fifth above G. And the way we do that is count up through 5 letter names, G, A, B, C, D. And that's going to give us our fifth. And we know it's a perfect fifth on this D here because the D is present in the G major scale. The G major scale goes like this, F sharp, G. So this D is present in the major scale, so that shows us that G and D is a perfect fifth, and so we can cross that off. And that shows us that our compound perfect fifth goes from this G down here up to this D because it's an octave plus a perfect fifth. And you can do that for any interval. So a compound major second will be an interval plus a major second, or actually an interval plus a tone. And a compound major seventh will be an octave plus a major seventh. Actually, almost 2 octaves. Just missing it by 1 semitone. Here's our C down here. If we wanted to make a compound major seventh, we need to go up an octave to this C and add on a major seventh, which gets us to B. So we've almost gone all the way up 2 octaves from this C to this C. We just made it 1 semitone smaller to give us our compound major seventh.